Okay, in this video we're going to talk about a certain type of organic molecule called a hydrocarbon. You've already seen hydrocarbons last week. The name is pretty easy to understand. These are molecules that have hydrogens and carbons. This is an example of a molecule that is a hydrocarbon. You can pause the video if you want and name it. It has 5 carbons in a row, so it's pentane. This is also a drawing of pentane. This is the skeletal drawing of pentane. This is the expanded structure of pentane. The formula for pentane is C5H12. You can count them up. And I'm going to tell you that molecules like this kind of hydrocarbon, is called a saturated hydrocarbon. In this case, saturated means that I have stuffed as many hydrogens onto these carbons as possible without breaking the rules that carbon has to make 4 bonds and hydrogen has to make 1. The largest number of hydrogens that I can stuff onto those carbons is 12. And so this molecule here is an example of a saturated hydrocarbon. It's saturated with hydrogens. This molecule over here is also C5, but it's not H12. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C5H10. This molecule here is not stuffed with as many hydrogens as I can stuff onto it because it has this double bond here. So this particular molecule is an example of an unsaturated hydrocarbon. So I want you to know what saturated and unsaturated hydrocarbons mean. In practice, unsaturated hydrocarbons are going to have at least one carbon-carbon double bond or a carbon-carbon triple bond in the molecule, which means you can't put as many hydrogens on as you could over here. If you remember from the previous week, this functional group is called an alkene functional group. So if you have a hydrocarbon with an alkene or an alkyne, which is a carbon-carbon triple bond, then your hydrocarbon will be unsaturated. If you have all single bonds, then your hydrocarbon will be saturated. If you've heard of saturated fats and unsaturated fats, the saturated and unsaturated here is related to what I am talking about here. With saturated fats, you have a fat molecule, and part of the molecule is a bunch of carbons and hydrogens, and with a saturated fat, this part of the fat molecule is all single bonds, and there are as many hydrogens on those carbons in that fat molecule as you can put on them. With unsaturated fats, the fat molecule has a carbon-hydrogen area where there's at least one carbon-carbon double or carbon-carbon triple bond, and that removes a certain number of hydrogens from that part of the fat molecule. I don't remember which one is good for you and which one is bad for you, but maybe you know that. So here's another example of a molecule that is a hydrocarbon that is unsaturated. This is also C5, 1, 2, 3, 4, 5. And how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. So this molecule's formula is C5H8. This is also unsaturated because it has this carbon-carbon triple bond. And if you remember, that is called an alkyne functional group. All right, so I want you to know the difference between saturated and unsaturated hydrocarbons. There are rules. If you remember last week, we talked about rules for naming alkane molecules and alkane molecules with substitutions. Alkene molecules are ones that have these double bonds between carbons. There are rules for naming these as well. The rules can get kind of complicated. I am not going to expect you to do much beyond, well, I'm not going to expect you to do anything beyond what's on this slide. I'm going to keep it very simple. When you have a double bond in your hydrocarbon, you count the number of carbons in the chain. It's 1, 2, 3, 4, 5, 6. So it's kind of like hexane, but it has this double bond, so it has an alkene. So instead of calling it hexane, we are going to call it hexene. And the only other thing we do for the name is we number the carbons from whatever side makes us hit the double bond first. So I'm going to number it like this. And we tell people what carbon the double bond starts at. It starts at 1. So this molecule would be called 1-hexene. You can pause the video and think about what this one would be called. We number the carbons as well. There are 6 of them. So this molecule is also going to have the end part of its name be hexene. And we have to number the carbons from whatever end makes us hit the double bond first. 1, 2, 3, 4, 5, 6. And we have to tell people what carbon the double bond starts at. It starts at number 2. So that molecule would be called 2-hexene instead of 1-hexene. That is the extent of naming rules for alkenes. I will not throw side streets on here or branches or anything else. That's as complicated as it would get if I asked you a question like this on a quiz or a test. Same general rules apply if you have a carbon-carbon triple bond. So here's a molecule with a carbon-carbon triple bond. 1 carbon, 2, 3, 4, 5, 6. So it's kind of like hexane because it has 6 carbons, but it has an alkyne functional group, so we're going to call it hexyne. Same thing, we number the carbons from whatever end it makes us hit the triple bond first. So 1, 2, 3, 4, 5, 6. And we tell people what carbon the triple bond starts at. It starts at number 1. So that molecule would be called 1-hexyne. This one over here, 2-hexyne. There is an alternate naming rule that you don't need to know. Sometimes this is called hex-1-yne, and this one would be hex-2-yne. You don't need to know that one. That one's a little bit weird. As long as you can do this kind of naming, you're in good shape. Okay, that is it for this video. In the next video, more chemistry, I guess.